Hey, our next lesson here is going to be on solving systems of linear equations by using substitution. Last lesson on solving systems of linear equations dealt with graphing them, and then where those two graphs or those two lines would intersect, that would be the solution. Well, I'm going to show you a different method in solving a system of linear equations by using substitution. Um, First off, I want you to think, let's look at a math problem here. Let's say we have x plus x plus 3 is equal to y. X plus 3 is equal to y. Well, they also tell you that x is equal to 5. So how are you going to solve for y? Well, you put a parentheses, you put plus 3 is equal to y, and what do you put inside that parentheses? Well, whatever x is equal to goes inside that parentheses, and in this case, x is equal to 5. Well, what if maybe x wasn't equal to only 5? What if x was equal to 5 plus y? What would you do then? Well, I like to think of this as like like say if you're out there playing football or soccer. Yeah, no, soccer? Hmm. Yeah, soccer, you could do that with soccer. Or, your baseball, softball, um, what's some other ones? That's probably maybe swimming. You could do swimming. Um, Maybe track and field if you are like a pole vaulter or like say a shot put thrower or a disc thrower. If you're a runner, yeah. So if we think about these different sports that I told you, like say your coach calls you up and says, "Hey, hey Jimmy," or "Hey Sally, you're in the game." Well, if the football coach calls up Jimmy and puts Jimmy in the game here, and Jimmy goes to play his football game, and Jimmy's pretty happy because he's getting in the football game, but Jimmy can't go play football looking like this. Jimmy's got to have a helmet on, and if Jimmy doesn't go in with the helmet on, then he's not going to be able to play the game. And that's just like this X right here. You can't just put 5 in there for X. You have to put 5 plus Y. You have to go in for X fully equipped. Fully equipped. Okay? So make sure you get that helmet on, Jimmy. Get that helmet on, Jimmy. It's a face mask there that way. Gotta make a thick helmet. We don't want any concussions. Make sure Jimmy can play the next game. And just a heads up, Jimmy's the quarterback. He might need those. Okay, so remember my whole point. X is equal to 5 plus y, so you put 5 plus y in for x. You put everything in for x. All right, so let's look at this. Here we have a system of linear equations here. Two equations, 3x plus 4y is equal to negative 4, and x equals negative 2y plus 2. You could graph those and find the point where they intersect, but just like in the previous lesson that I showed you, you don't always get an exact answer when you use graphing. So let's look here. Let's look and see what we have. I'm going to take this, since we have x is equal to negative 2y plus 2, I'm going to substitute negative 2y plus 2 into the top equation for x. So this is going in right here for x. So let's look at this here. Look at what we've done here. Top equation, right? 3x plus 4y equals negative 4. It's the same. And now look at what I've done on the second line below. There's a big parentheses there. And what is that parentheses for? Well, I have x. Well, what is x equal to? Well, if I look right here, x is equal to negative 2y plus 2. So I'm going to take this negative 2y plus 2, and I'm going to plug it right in there for x. And you might say, hey, why would we do this? Well, if we look at this problem here, we have x and y. They're not like terms. You cannot combine those. But let's look at this problem here. We have a y. We have a y. Do you see an x in there anywhere? Are you sure? No x? No x is a good thing because y and y are like terms. Now you can solve this out for y, and then you'll plug it back in and solve for x. Oh, let me get rid of some of this stuff here so we can do our work. Well, we know if we have this 3 outside the parentheses, the distributive property will work here. 3 times negative 2y is negative 6y. And 3 times 2 is 6. Is it a positive or negative 6? Positive 6, so we put a plus 6 there. We drop down plus 4y, and we drop down negative 4. Now, if we're looking on the left, we have on the left side of the equal sign here, we have negative 6y and positive 4y. Since they're on the same side of the equal sign, we go ahead and just do what it tells us to do. Negative 6y and positive 4y. What's negative 6 plus 4? It's negative 2y. So we've used this and this to make negative 2y. We drop down our positive 6, and let's see, what do we have here? Negative 4. It's equal to negative 4. All right, how are we going to solve for y? Subtract 6 from both sides. So negative 2y is equal to negative 10, and then we divide both sides by negative 2. Negative 2's cancel, so now y is equal to, what's negative 10 divided by negative 2? Negative divided by negative makes a positive, and 10 divided by 2 is 5. So y is equal to 5. If we look here in our ordered pair, y is equal to 5, so that goes on the right side. Now, if y is equal to 5, what's x equal to? Well, we just take that 5, we substitute it, we can substitute it into either place to solve for x. I'm only going to substitute it into the bottom equation because it's going to be less work to figure out what x is because x is already by itself here. So let's go ahead and substitute that in for y. Let's do our work over here. X is equal to negative 2 times y. What's y equal to? Right here, 5 plus 2. And solve this out. Negative 2 times 5 is negative 10 plus 2. And negative 10 plus 2, negative 8. X is equal to negative 8. So your solution to the linear system of equations is negative 8, 5. Those two equations that we started out with will cross at that point right there, negative 8, 5. Basically, you have to solve for one variable, substitute it in, and solve for the other variable. Let's look here. These two equations are a little bit different than this one here. This one here, look at x. X was already by itself. It said x was equal to something. The two examples that we're doing now, they don't have x is equal to something, or we could figure it out if y was equal to something. It's those variables are not by themselves. But I'm looking here, and I notice that there's a 1 in front of that x. So I can easily get x by itself. Let's look at the bottom equation. How can I get x by itself? Let's add 5y to both sides of the equal sign. So x is equal to 5y plus 11. And so now we take the top equation, 2x plus 7y is equal to negative 3. Since we have x is equal to something, and this is what it's equal to, down here we're going to write 2, big parentheses, plus 7y is equal to negative 3. Now why did I put that parentheses right there? Is because it's going in for x. What do we have that's going to go in for x? 5y plus 11 goes in for x. And 5y plus 11 will go in for x. And now we can solve for y because now we have y as the only variable in the equation. Let's work the distributive property here. 2 times 5y is 10y. 2 times 11 is positive 22. And we drop down everything else. Let's combine like terms. 10y and 7y. 10 plus 7 will give us 17y plus 22 is equal to negative 3. 7 and the 10 go together to make 17y. And a lot of you might say, well, how come I'm not going to subtract 10y from 7y? Well, if we had something like this, where 7y was on the right side, if 10y and 7y are on the opposite sides, you have to use opposite operations. So there you would subtract 10y. But if we look in the example that we are actually working in, they're on the same side. And that's just a problem that you've always done for your whole life. 5 and 7 are on the same side of the equal sign, so 5 plus 7 is 12. That's equal to x. If they're on the same side, you just always do what it tells you to do. So let's go ahead and solve the rest of this. Subtract 22, subtract 22. 17y is equal to negative 25. And divide by 17. Divide by 17. So y is equal to negative 25 over 17. Negative 25 over 17. That's what y is equal to. Okay? And then so from here, we just plug it back in for y and solve for x. Okay, so we're looking here. We're looking to solve for x. Well, we already know what y is, so we're going to plug what we have in for y. We're going to plug it right in there for y, because that'll give us what x is equal to. So we have x is equal to 5 times negative 25 over 17 plus 11. 5 is 5 over 1 times 25 over 17. There's no reducing. 5 and 17 don't reduce. So 5 times 25 is 125. 1 times 17 is 17. I know the 5 was positive, and this number 25 over 17 was negative. So that's going to give me a negative. So I have negative 125 over 17, and I'm going to add 11 to it. But I know that I have to have a common denominator in order to add these together. So common denominator between 1 and 17, that common denominator is going to be 17. So if you have to multiply the bottom number of 1 by 17 to get 17, you have to multiply the top number of 11 by 17. And 11 times 17, I believe it's 187. 17, yeah, 187. And so now this is what we're working with. Sometimes you get fractions in these problems, and sometimes you don't. And if we were to graph this, we probably wouldn't have gotten an exact answer. We probably would have been, close, but not exact. So we have negative 125 over 17 plus 187 over 17. So negative 125 plus 80 or plus 187. That's going to give you something like 62 over 17. And we write our answer up here, 62 over 17. Remember, this is a negative 25 over 17. So there is your exact answer, your exact solution to that linear system. 62 over 17 and negative 25 over 17. You can plug it back in for x and y in both equations to make sure that the left side of the top equation is equal to negative 3. The left side of that top equation equals negative 3, and then the left side of the bottom equation equals 11. Let's look here. Which variable is it going to be easy to get all by itself? This y right here has a 1 in front of it. I know it's a negative 1, but at least has a 1 in front of it. The other ones will have numbers. So let's add y to both sides of the bottom equation. So 3x is equal to 8 plus y. We're trying to get y by itself, so we minus 8. So 3x minus 8 is equal to y. If you chose in the very beginning, you could have subtracted 3x from both sides and then either multiplied or divided everything by negative 1 to get y by itself, and you still would have gotten this same part right here. 3x minus 8 was equal to y. So now let's look at the top equation here. Remember, we're substituting in for y, so right there's y. So let's substitute n for y. So 4x minus 2. What's y equal to? 3x minus 8. And so this is where we're at. We notice we have an x and we have an x, so those are like terms, which is a good thing. Let's distribute. What number are we distributing to 3x? Look at that number. If you've said 2, you forgot to look at the sign. What's the sign in front of 2? It's a negative 2. So negative 2 times 3x is going to give us a negative 6x. And negative 2 times negative 8 will give us a positive, negative times a positive 16. And we drop down 4x and negative 1. Go ahead and combine like terms. 4x minus 6x will give us a negative 2x. Drop down 16 and negative 1. And I believe in order to get x by itself, we should subtract 16 from both sides. So subtract 16 from both sides. You get negative 2x is equal to negative 17. In order to get x by itself, you divide by -2. X equals 17/2. You got it. Okay, I think we're rolling now. So we know what x is equal to. Are you going to put that on the left side or the right side of this inequality? Or not inequality, the left side or the right side of this ordered pair? You put it in the left side because it's x. 17 halves. So that's what x is equal to. X is equal to 17/2. All right, well, let's look here at this. Y is equal to 3x minus 8. Well, since y is equal to, let me get a different color here. I feel like, yeah, green. 3x minus 8. What's x equal to, though? 17 halves. 3x minus 8. So if we're trying to multiply 3/1 times 17/2, multiply the top numbers. Was 3 times 17? And the bottom numbers, 1 times 2. So we have 51 halves. We're going to minus 8. Now remember, it's 8/1. What's the common denominator between this 1 and the 2? It's going to be 2. So you had to multiply the bottom number of 1 by 2 to get the 2. So you have to multiply 8 by 2 to get 16. So this is what we have. 51 halves minus 16 halves. So 51 minus 16 is 35/2. Remember, that's y. So we're going to put 35/2 in our problem there. So that's our solution. 17/2, 35 halves. 17 halves, 35 halves will be our solution. Let's I'll work through this one, and then there's 2 more, so I'll let you try those last 2 on your own. When you look at this problem, you should be thinking, which variable is it going to be the easiest to get by itself? So which variable here? X has a 6 and a -18 with it. This bottom y has a 3. This one has a -1. I like that -1 better than I like the other numbers, for the simple fact that it's easy to get rid of. It's easier to get rid of than the other ones. So how do we do this? Let's go ahead and rewrite it over here. 6x minus y is equal to -2. Subtract 6x from both sides. So we're left with -y is equal to -6x minus 2. And how do we get rid of that -y? You can divide everything by -1, or you can multiply everything by -1. They do the same exact thing. Make sure it's everything. So -1 times -y will give you a positive y. -1 times -6 will give you a positive 6x. And -1 times -2 will give you a positive 2. So now we know what y is equal to. And we can take it and plug it right into the other equation for y. So -18x plus 3y. But what are we substituting in for y? 6x plus 2. I don't know how you guys figured that out, but you did. Must mean you're doing something right. So if we're looking here, now we have all x's, so we can combine those like terms when we get to that point. We have a positive 3 outside, so let's distribute. That's going to be 3 times 6x is a positive 18x, and 3 times 2 is a positive 6. And so if we look, negative 18x plus 18x will give us 0x, and 0x is just 0. So 0 plus 6, 0 plus 6 is 6, so 6 is equal to 4. And so, where'd the x go? Well, the x is the x is canceled out right there. Is that possible? That is very, very possible. You've made a good choice if this is where you've ended up. If we look here, 6 is equal to 4. Okay, if 6 is equal to 4, then you probably wouldn't be as confused. But 6 is not equal to 4, so we're gonna put the line through there. 6 is not equal to 4. We don't have a variable to solve for here. There's no variable there. There's no x there. So we can't go any further here. When you get to this part where it says a number is not equal to another number, when this where it said 6 is equal to 4, when that's not true or not equal to, then your answer is no real solutions. And the whole point of this is that these two lines, those two lines are going to be parallel. They will not be intersecting, so that's why there's no real solutions. So that's your answer there. You don't have to go any further, because even though you know y equals, you don't know what x is equal to, so you can't solve for y. No real solutions is the answer here. Look here. Figure out which variable you want to get by itself. If you feel comfortable enough, go ahead and solve this one on your own, and then check your solution, or solve it out as far as you can get, and then check your solution up until that point. And then if you're right, then pause the video and go ahead and work out the rest of it, and make sure that just try and do as much of this on your own as possible. I'll go ahead and pause the video, and then I'm going to work it out. So if I'm looking at this, I like the top equation, because right there, x has a 1 with it, has a positive 1 with it, and that's even better than a negative 1. So has the positive 1 with it. So how do I get x by itself? So we have x minus 5y is equal to 9. Well, let's look. X is on the left side, and so is this negative 5y. So what's the opposite of negative 5y? It's going to be positive 5y. So those cancel. X is equal to 5y, and the 9 is positive. See the little positive sign up there? It's invisible until I just wrote it in there. So the 9's positive. So this is what we're looking at. X is equal to 5y plus 9. What are we going to do with that? Plug it in right there. So let's go ahead and do that. 2 times x. What's x equal to? 5y plus 9. 5y plus 9. And then it says plus 3y is equal to 5. Let's go ahead and distribute. 2 times 5y, 2 times 5 is 10y. And 2 times positive 9 is a positive 18. If we notice, we have the y's are both on the same side of the equal sign, so we just go ahead and add those together like we combining like terms. 10y plus 3y, 13y. We just drop down that positive 18, and we drop down the 5. Trying to get y by itself, subtract 18. So 13y is equal to negative 13. So this is not like the last example. We still have the variable here. We can solve for y. Divide both sides by 13. So the 13's cancel. So y is equal to a negative divided by a positive is a negative. 13 divided by 13 is 1. Excuse me there. So since y is equal to -1, we can plug it right back in there for y and solve for x. X is equal to 5 times y. Remember, y was -1. 5 times -1 is -5 plus y. And I'm sorry, 5 times -1 is -5 plus the 9. And -5 plus 9 will give us a 4. X is 4, y is -1. So the answer to your system of linear equations there is 4, -1. I hope you've taken some thought to try and figure out which variable you want to get by itself. In the top equation, you have -x, which is a good one to work with. You have -1 in front of x. Or in the bottom one, you have a positive y, which that's the one I want to work with. So in order to get y by itself, we subtract 2x from both sides. So y is equal to -2x plus 15. Well, we know y is equal to -2x plus 15, so it gets substituted into the top equation for y. So we have -x minus 4 times y. What's y again? -2x plus 15. And that's equal to -3. Let's go ahead and do some distribution here. What number is being distributed to -2x? It's -4. Look at the sign in front of the 4. It's negative. So -4 times -2x is a positive 8x. And -4 times positive 15. A negative times a positive is a negative, and 4 times 15 is 60. Drop down everything else. Let's go ahead and combine like terms here. -x plus 8x will give you a 7x. Drop everything else down. And how do we get x by itself? We're going to add 60 to both sides. So here we have 7x is equal to -3 plus 60 is 57. Divide by 7, divide by 7. X is equal to 57 over 7. Let's go ahead and write that into the ordered pair. So that's what x is equal to. Well, we could take this 57 over 7 and plug it in there for x and work it out and solve for y. We could do that. Since you already know how to do that, I'm going to show you another method, and I think this method works out quickly because the x is almost by itself there. It's almost saying x is equal to something. So instead of substituting in for x to solve for y, I want to show you another method that you can do, which is very similar to what we've been doing. Um, let's take this top equation here. So negative x minus 4y is equal to negative 3. Let's get x by itself. So we add 4y to both sides. So we say, since we added 4y, it was a positive 4y. And what about the 3? The 3 is a negative. So how are we going to get x by itself if it has a negative 1 with it? Multiply everything by negative 1. So that becomes negative 1 times negative x becomes positive x. Negative 1 times positive 4y is negative 4y. And negative 1 times negative 3 is a positive 3. So now x is equal to negative 4y plus 3. Well, we can take this, plug it in right there for x. So 2 times x. What's x equal to? Negative 4y plus 3. And bring down the rest of this. Plus y is equal to 15. So now let's go ahead and work this out. 2 times negative 4y, negative 8y. 2 times 3, 6. Drop down your y and your 15. So now we have negative 8y and positive y. Negative 8y plus y is negative 7y. So we've used this and this. So let's drop down our 6 and the 15. Trying to get y by itself. So we're going to subtract 6 from both sides. So 15 minus 6 will give us a 9. And go ahead and get y by itself. So y is equal to negative 9 over 7. And we go ahead and write that in up here. It doesn't matter how you solve for y. You could have plugged in 57 over 7 into what we said y was equal to on the previous, before I erase this. And you would have gotten negative 9 over 7. Or work this out. I felt this was just as quick as working with the fractions. It was, 6 to 1, half dozen to the other as far as quickness in getting it done. So either way would work. It's just, this isn't just another different way. And it works quickly because we were able to get x by itself fairly quickly. So if you have any questions about that one, let me know. Well, that brings us to the end of this. Yeah, solving linear systems by substitution. This is the second part of solving linear systems. We do have one more to go, which is linear combinations, which is coming next. So, and then after that, you'll be good to go in solving linear systems. Well, hope the rest of your day is good, and I will see you on the next trip.